Well, I'm glad you returned for this part 2, where we're going to go ahead and check out T1 and T2 coils. So that's actually 1, 2, 3 coils of T1 and 1, 2, 3 coils of T2. It's going to be a piece of cake, trust me. Over here are 3 wires going off the chassis. These are your antenna wires, and you see one comes down, goes over here to the band switch, and the other 2 come down and go into the coils. It's an orange one, a black one, and a blue one off the chassis. So I'm looking around for wires that go off the chassis, and guess what I have found? I have a black one right here. Come on now, separate, boys. I have a black one right here that goes off the chassis, and next to it is a blue one. So I have these 2 right here. And then I have this white one. Well, let me see, we got black and blue, but there's supposed to be an orange one. Instead, we got a white one. Now, how did that happen? Well, it's obviously an antenna wire of some kind, only it's white. Now, could it have been orange at one time and just all bleached out? Probably not. It just seems to me there would have been at least a little bit of orange on it somewhere. Well, I got looking at it, and it goes in to the proper connection on T1. And right down in there, let me get this light over here. I want to kind of show you something. Now, these things are, sometimes they seem complicated. But I want you to understand they're not complicated, okay? These radios are pretty simple, really, if you just take it a small piece at a time. Now, I found this white wire. Now, some people say, oh my God, what is that? It's supposed to be orange. I don't even know what this is. Where did it go to? Well, think about it for a second. We go down in there and we look at the connection, and guess what's right there? I don't know if you can see that or not. I wish you could. I wish my camera was a little better. But there is a stub. Let me see if I can zoom in a little bit to help you. You see that stub right there? That's a stub of a wire. And when I got looking close, the insulation was tinted orange. So what's happened? And it looks like it was done at the factory. That orange wire that was there was clipped off, and in its place was soldered this white wire. It goes to the correct connection where the orange is supposed to go on T1. So I think I've solved our problem. We have the black, the blue, and what is supposed to be orange is now white. Okay? Piece of cake. We don't have all kinds of, headaches over this. That was easy to figure out. Not confusing. It's only 3 little wires. Okay, let's go ahead and check out T1. And I'll get the multimeter set up. By the way, I decided to use the analog meter today, so if we have any continuity, you can see the needle move. Now look, we're just looking for continuity today. Whether it says 7 ohms, 12 ohms, or 15 ohms, or 3 ohms, it doesn't matter. I'm looking for continuity. I want that needle to swing and show me that the wires going in and coming out of that coil, according to the schematic, have continuity and are in one piece. So let me get that thing set up. Alright, we're ready to rock and roll here. The orange wire, or in this case, the white wire, comes down, goes through this coil right here, swings on around, comes up and goes over, and goes through this coil right here. Then it comes on over, comes down to ground. Got that? Through the coil, up and around, through this coil, over to ground. So all I have to do is I hooked an alligator wire to the lead on my multimeter. I'm going to go ahead and connect that right there like that. Alright, we're now connected to the end of the orange wire. Now let's take the black, let's set this thing up for, I don't know, let's just set it up for R times 1, I guess will be okay. Make sure we got continuity here. Always check continuity before you begin. Okay, the needle moves, okay? I can't tell you how many times when I first started doing this sort of thing, I couldn't figure out, it wouldn't work. And come to find out that the connection was bad, or the battery was dead in my multimeter. So you always check first to make sure your multimeter is working, and it is, in particular on these analog meters. Alright, we're connected to orange right here. and it's supposed to go all the way down around to ground right there. So that means if I touch this thing right here, which is connected to ground, or any other part of the chassis is connected to ground, I should get a multimeter movement. Let's find out. Touch. Look at there. All the coils are good. Alright, we've checked this coil and this coil down to ground. Now we have to check this one right here. Now this coil comes off of the variable capacitor. That's what that capacitor with the arrow through it right there means. Okay, it comes off the variable capacitor. It comes over down through the coil again to ground. That's a blue wire, by the way. So let's look for a blue wire going to the variable capacitor that comes off of T1 rather. And there it is right there. Let me get the lamp around here. Hopefully we can see it a little better. There's the blue wire right there that's hooked to the bottom of the variable capacitor. It's soldered up right there, and it goes to T1. So I should be able to take my trusty little alligator clip and put it right where that wire is soldered, and again touch the chassis because it is hooked down here to ground. Remember that. I should be able to get a reading also. Let me turn out this light. It might affect the way it looks. Okay, here we go. Here we go. I'm going to touch the chassis again. Touch. It's good. It is good. Touch. All right. See how easy that was? This stuff is a snap. Anybody could do this. We now have this coil good. This coil good down to ground. And we now have this coil good. I declare T1 good to go. At least it's got continuity. Whether or not it works is another story. It's got continuity. Let's move on to T2. Now T2 looks a whole lot more complicated than T1 was. Actually, in the beginning it probably looked pretty complicated, but now that I've shown you how easy it really is, it's not so complicated anymore. None of this stuff is complicated. T2 also has 3 coils. It's got 1, 2, 3. Now, one side of T2 has a blue wire also that comes around and goes down to the variable capacitor. And then it goes through all 3 coils to a yellow wire on T2. So what we need to do is find the yellow wire on T2 where it connects to the last coil. And we also need to find the blue wire that goes over and connects to the variable capacitor, which should not be difficult because we already know that this was the blue wire for T1. So if I look around here, sure enough, there is a blue wire right there going to the bottom of the variable capacitor under there. That's going to be a little bit more difficult to get to, so let's see if we can't find a connection point on the coil itself. And there it is right there. There's the wire going over to the bottom of the variable capacitor. That is this blue wire. Now see how easy that was? I mean, that was just a piece of cake. So we're going to go ahead and connect on right here where that blue wire is connected. A lot easier than trying to get up underneath there and maybe destroy something. I've got to be real careful here. Okay, I'm going to make sure I got a good bite on there with that. Okay, now if everything goes right, all I have to do is find the yellow wire and connect it, and I hopefully will get continuity again on our meter. So let's find out. Let me see. Here's our multimeter probe. Let me get this light out of the way. Alright, there's the yellow wire laying on the chassis right there. See it? That's the yellow wire. All we got to do is follow it to where it's connected. It goes down through the chassis. And of course it does, if you look at the schematic, it does go down through the chassis because it goes down here and it hooks onto this wafer switch, the band switch, which is underneath the chassis. So we got the right wire. Now let's see where it connects onto the coil. There it is right there. It connects on right there. Let me see if I can get the lamp over here to help out a little bit. Just a little bit. There it is right there. Right there. I don't know if you can see that or not. So what I'm going to do is I'm going to get this thing over here. Let me switch cameras to my other hand and see if I can't get this thing where it Let's see if I can get some continuity here. Touch. There it is. All 3 coils are good on T2. Is that cool? Of course it's cool. Alright, we know that T1 and T2 are both good, but I'm worried about this wire hanging here. I'm afraid I'm going to pull it and yank it out of the side of the coil and ruin something. So, we're going to take care of that right now. We're going to cut that off of there. We don't need that anymore. And now the wires are too short to actually cause any damage unless I actually pull on them. Alright, the next thing we are going to do, you're going to love this. The next part of this video, I was going to go ahead and finish up T1 and T2 and then move on to one of the IF cans. I decided not to do that. Instead, we're going to check out T3, the oscillator coil. I remember one time I kept calling this an oscillator, and someone on the Antique Radio forum chimed in, oh, now, John, that's not the oscillator. The oscillator is a complete circuit. That's just the oscillator coil. He was right. So we're going to check out the oscillator coil, even though sometimes I refer to it as the oscillator. What we've got here is a yellow wire coming off the tube, coming off the screen grid of the tube, coming down and connecting to one point on the oscillator coil. It goes down through the first coil, down through the second coil to a brown wire. So all we have to do is find the yellow wire and the brown wire and measure the continuity between them and hope that we get continuity. Let's take a look at the radio. Alright, there is the yellow wire. Plain as day. The brown wire is right here. Doesn't look like a brown wire, but it actually is. Got a lot of dirt and dust on it. So here's what we're going to do. Instead of hooking onto the coil, I don't want to take any chances. I'm just going to follow the wire over and hook onto the tube pin. Same place, same electrical point. I just don't want to take any chances of messing up those pins. This is an old brittle unit. Now, let's see if I can get some light over here before I go any further and muff anything up. Let me see if I can find that brown connection. Okay, here's the brown connection. Right down in there. I can see it. I know you can't. I want you to kind of keep your eye on this meter here. I'm going to touch it, and if I get some continuity, that means that side of the oscillator coil is good. Here we go. Touch. It's good. Look at that. Look at that. Touch. Oh, this is great. This is great. All right. These 2 coils are good because I just, got continuity between these 2 points, the yellow wire and the brown wire. Alright, let's go over here and do the other side. Now this is a critical coil. Without this coil, we're dead in the water, folks. It would just about shut the entire project down, so let's hope that this side is good. Alright, what we've got here is a mica capacitor that has a black wire connected to it coming from here. Goes down through the coils, down to another connection. See that arrow through the cap? That's another connection on the variable capacitor. So we should have a black wire that hooks to the variable capacitor from this connection. And then we should also have another black wire that goes down below the chassis. Here's what we have. We have 2 black wires. That's what we're looking for. We have 2 black wires right here. Let's see if I can zoom in here and make it a little better. One wire goes up through the chassis to the top of the chassis. Now, where do you think that wire is going? You better believe it. It's the one that goes up and is connecting to the bottom of the variable capacitor. Now, remember, we had a wire on the left of the variable capacitor. We had a blue wire on the left. We had a blue wire on the right. This black wire has to be the one that goes to the center. Let's find out. Let's find out. We're going to kind of bring it on down here. Get this out of the way. And there it is right there. There's the black wire. Let me get this one out of the way. This black wire right here goes over and connects right there. There it is right there. That's the black wire we want. Okay, now we've got one of the black wires. This stuff is so easy. God, this is so easy. You can do this in your sleep, guys. So we now have this black wire identified. The other one is a black wire that goes up to a mica capacitor. Another black wire coming off the oscillator coil going to a mica capacitor. Let's see if we can find a black wire coming off the oscillator coil going to the mica capacitor. Well, I see the mica capacitor already. There it is right there. It's that brown thing hidden behind this booger here. See that right there? For all you guys that like my pencil tapping. It's right there. Okay, now all we have to do is find the wire that comes off the oscillator coil to the capacitor, and it's a black wire, and there it is right there. That's it. That's the one right there. So what we need to do is we need to connect one part of the multimeter to this wire right here. This is the one that goes up through and connects to the variable capacitor, you'll remember. Now let's take this right here. Y'all keep an eye. I'm going to be touching this. I'm going to be touching this right here, right where that black wire connects onto the coil. I'm going to be touching that right there. And if it shows continuity, that means that the left side of that coil is good. Let me turn out this light. Make it a lot easier. It's affecting the camera. Yeah, there's the wire I'm going to be connecting to right there. Here we go. Here we go. Touch. There it is. Look at that, folks. Looky there. You know what that means? T1, T2, and our oscillator coils all have continuity and appear to be good. And with that, next time we're going to do the IF cans. So until next time, I hope you all got something from this. The main thing I wanted you to understand was it's not that difficult. Take it piece by piece by piece. Take out little sections of your schematic, like I've said in the past. Work at it a section at a time. You can figure this out. If I can do it, anybody can do it. Until next time, this is John.